Hello everyone. So here is today's problem. In a short shunt 200 volt DC generator supply 20 kilowatt where the armature resistance is 0.4 ohm, the series resistance is 0.2 ohm and the shunt resistance is 50 ohm. Find the total armature current and the generated EMF. So here we have a term called short shunt. So far we haven't discussed this short shunt, and to discuss that we need to explain a little bit about the types of generator. So these DC machines are actually categorized according to their connection of shunt winding and the series winding. Okay, so one is separately excited. Here the field winding are actually not connected to the armature. So this is connected with a separate voltage source to provide the field flux, and the others are self-excited where the field connection are actually connected to the armature. Alright. Now this self-excited we can categorize in different terms like series, shunt, and the other is compound. Whereas this compound is actually the combination of series and shunt. We have already discussed the series and shunt type of machine before. So how does the compound machines look like? So there will be both series and shunt, right? So here we have the series winding and we can connect the shunt winding here. Now you see, we can connect the shunt winding in a different position like here also. Right? This is also acting as a shunt. So this is two different type of connection. So in the first one we call it long shunt. So you can see just the shunt connection is covering a longer portion where it is also covering the series connection and series winding and the armature, and in the short shunt it is just across the armature. Okay, so now I hope you understand the long shunt and short shunt type. Okay, now in this compound type of machine there is another two categories. One is cumulatively compound and differential compound. Now what is this two type? So in cumulative, the flux generated by the series and shunt gets added up. Okay, so this is addition of flux. And here differential, you know what is the meaning of differential, right? So differential is actually reduction is plus, or better to write difference in flux. Okay, so one flux will be opposing the other flux. Okay, so these are the types of different connection. Now coming back to the problem. Now I think you can try to solve it, and then I will solve the problem. Okay, so let's just draw the connection of short shunt first. Here we have the series winding and the short shunt connection. Okay, that's the generator and the rating is given as 200 volt. So here if we connect the load, so here we will have 200 volt. Now it's saying this that supplies 20 kilowatt. Now what is the meaning of supply 20 watt? That means in the output we are getting 20 kilowatt. Okay, that is the supply rate. And the armature resistance is 0.4 ohm. Let's just draw it here. 0.4 ohm. And our AC series winding is 0.2 ohm and the shunt is 15 ohm. Find the total armature current. Now you see that the output is 20 kilowatt. So output power is, we know, that is Vt into IL. Correct? Now Vt is 200 volt and IL is IL we have to find. So IL you will get 20 kilowatt, so 20,000 by 200. So that will be 100 ampere. So we found that the load current is 100 amps. Okay. So if we see the voltage drop across the series winding, so VSE is voltage drop across the series winding will be 100 into 0.2 ohm, so that will be 20 volt. Okay. So the voltage across the shunt winding will be 200 plus 20, that will be 220 volt. Okay. So now we can find the current through the shunt winding. So that will be ISH be 220 above 50. So that will be 4.5 ampere. Okay. So now we can find the armature current. So since both the shunt current and the load current is coming out from the armature, so the armature current will be the sum of both the currents. So that will be 100 plus 4.5, so that will be 104.5 amps. So this is one answer. Now we need to find the EG. So you see there is another resistance, there is the armature resistance, and obviously there will also be some voltage drop because of the current. So the voltage drop across the armature current, let's say VRA, is 104.5 into 0.4, that is 41.8 volt. Okay. So now if we need to find the EG, that's the generated EMF, that will be sum of this 220 volt and the voltage drop 41.8. So that will be 261.8 volt. Fine. So I hope this is clear now. Alright. So now you have to do a homework, and the homework is just find this same armature current. Write it here. Find the IA and EG for long shunt connection. The answer will be 104 amps and 262.4 volt. So still, if you have any doubt, please write in the comment section. Thank you.